Everyone. Today we're going to be completing our notes on 8.3 quadratic functions in standard form. I want to start with this warm-up. We're going to take a look at four graphs and we're going to find the x and y intercepts for each of these. The first one's already done for you. So as a reminder, recall that the x-intercept is where the graph crosses the x-axis and the y-intercept is where it crosses the y-axis. So if we're looking at this here, the x-intercept is 4, 0, that occurs right here, and the y-intercept is 0, -2, that occurs right there. For the second graph, I notice that we have two x-intercepts. It crosses the x-axis twice, once at -3, 0, and another at 4, 0. It's got one y-intercept, and that's at 0, -3. Okay. The next one has one x-intercept at 1, 0, and one y-intercept at 0, 2. Okay. And last one, we have one x-intercept at -2, 0, and one y-intercept at 0, -4. All right, so take a look at our responses here. What do you notice is common to all the x-intercepts? Take a look at all these x-intercepts. What do they all have in common? Well, I notice that for all of the x-intercepts, the y-coordinate is 0. And likewise, for all the y-intercepts, what these all have in common is that the x-coordinate is 0. And while this is the case for the four graphs that we've seen here, this is true for all x and y-intercepts. The x-intercepts, the y-coordinate is 0, and the y-intercepts, the x-coordinate is 0. All right, so let's just recall some of these key points of a parabola. The graph of a quadratic is called a parabola. The x-intercept, and I'm going to say parentheses s, x-intercepts are the pointer points where the parabola touches the x-axis, touches, crosses. There can be 0, 1, or 2 x-intercepts for quadratics. The y-intercept is the point where the parabola touches the y-axis. There's always exactly one y-intercept, always. The vertex is the maximum or minimum of the parabola, the highest point or the lowest point. And through the vertex is the axis of symmetry. The parabola reflects over this line. So what that means is the parabola is completely symmetrical over this line. It's a vertical line, and the equation for the axis of symmetry will always be in the form x equals, and then whatever that x coordinate is for your vertex. All right, so number one, let's use these graphs here, and let's go ahead and find the x-intercept, the y-intercept, vertex, and axis of symmetry. All right, so first things first, we'll start with the axis of symmetry. I notice that it is right here. So the equation here is x equals -1. It's that vertical line. Okay. For the x-intercepts, we have two of them. We've got one right here and one right here. So one at the origin, 0, 0, and one at -2, 0. Y-intercept, we always have exactly one. And again, that's at the origin. Okay. The vertex is that minimum, that lowest point, that's at -1, -3. Always do that double check. Is the axis of symmetry x equals the x coordinate of your vertex? In this case, yes, it is. All right, graph B, we'll start with axis of symmetry. It's that vertical line that cuts the graph in half. So the equation for this line is x equals -3. X-intercepts, we've got two. We've got one right here and one right here. So -2, 0 and -4, 0. Y-intercept, we have 1, but we can't tell exactly where it is because the graph doesn't show us all the way down. If we were to expand the window, we would probably expect it to be right here. All right, so we're just going to say it is 0 and then a negative number. I don't know what negative number it is. It could be like -8, -9, something around there. Because it doesn't show us on the graph, we can't say for sure. So we'll just say it's a negative number. Finally, the vertex is this point right here, is negative 3, 1. Okay, double check. Axis of symmetry, x equals negative 3, vertex, negative 3, comma 1. Excellent. Graph C, we have an axis of symmetry. It looks like it's right through the middle here. It's a little hard to tell, but it looks like it's right in the middle of 0 and negative 1. Okay, we don't know for sure yet, but we'll see later on in these notes. There is a way that we can find that. So for now, I'm just going to approximate x equals negative a half. For the x-intercepts, we've got 2 of them. We've got negative 2, and we've got 1. Okay. The y-intercept, we've got exactly 1 at negative 2, so 0, negative 2. And then vertex, again, this one's kind of hard to tell. It looks like it might be like a little bit less than negative 2 for the y, maybe negative 1/2. We'll say negative 2.2, we'll say. We're not sure what that is. We can't say for sure. Okay, let's talk about the axis of symmetry. Given the standard form for a parabola, which again is ax squared plus bx plus c, all of the quadratics in this section will be in standard form. The axis of symmetry can be found using the equation x equals negative b over 2a. All right, so let's try it with this example here. Y equals 2x squared minus 4x plus 5. A is equal to that leading coefficient, 2. B is the coefficient of the linear term, negative 4. Therefore, x equals negative b over 2a is negative 4 over 2 times 2. The numerator, that double negative cancels, and we get positive 4. In the denominator, 2 times 2 is 4. This reduces to 1. So therefore, the axis of symmetry is x equals 1. All right. Now let's find the vertex. So as a reminder, the x value for the vertex is where we have our axis of symmetry, because the axis of symmetry passes through the vertex. The x value of the vertex will always be the same, negative b over 2a. So to find the y value, solve for x using negative b over 2a, and then plug in your solution for x and solve for y. All right, so using the same quadratic, 2x squared minus 4x minus 5. Oh, this is minus 5. So this isn't going to change still. We'll still have an axis of symmetry, x equals 1. We're going to take 1 and we're going to plug it in for y, for x here. I'm actually going to make that a little bit clear. We're going to plug that in for x here, and then solve for y. So y is equal to 2 times 1, quantity squared, minus 4 times 1, minus 5. Y is equal to, well, we have 1 squared is 1, times 2 is 2. Minus 4 times 1 is 4, and then minus 5. 2 minus 4 minus 5 is equal to negative 7. So the coordinates for the vertex is 1, negative 7. Now let's talk the y-intercept. The x value, like we saw in our warm-up, the x value of the y-intercept is always 0. So to find the y-intercept, just plug in 0 for x and solve for y. So plugging in 0 for x, we get y is equal to 2 times 0 squared minus 4 times 0 minus 5. Well, I noticed that 0 squared is just 0, times 2 is still 0, 4 times 0 is 0, and then minus 5. 0 minus 0 minus 5 is negative 5. So our y-intercept is 0, negative 5. This point can be reflected over the axis of symmetry. So the reflected point, I notice that 0, negative 5 is just to the left of our vertex here, 1, negative 7. So therefore, the reflected point is going to be just on the other side of that. So our reflected point is going to be 2 and then negative 5. So one way we could see this graphically is if we were to plot our vertex of 1, negative 7, that would be right here, and then our y-intercept 0, negative 5. then our reflected point, I know that our axis of symmetry is x equals 1. So the reflected point is going to be right on the other side there. All right. So now that we have these points, we can start to see this U shape here. Let's go ahead and sketch in this graph. Make sure that it's a nice U shape. Extend it all the way through the graph, point it all the way up, cross through the x-axis here. Don't forget those arrowheads. And then last thing, make sure these are U shapes, not V shapes. So make sure that it's nice and curved at the bottom of the parabola here. All right, so let's get some practice. Graph the parabola y equals x squared minus 6x minus 1. All right, so first thing, we're going to find the axis of symmetry. Remember, that's negative b over 2a. Well, I know that b is negative 6 and a is the leading coefficient. In this case, there's nothing written in front of x squared, so a is equal to 1. So negative b over 2a is equal to negative 6 over 2 times 1, which is equal to 6 over 2, or 3. So the axis of symmetry here is x equals 3. I almost forgot. I noticed that this parabola opens up because a is positive. The leading coefficient is 1. It's positive 1. So automatically, we have x equals 3 as our axis of symmetry. We can go ahead and sketch that in right now. The vertex, because this opens up, we know that the vertex is going to be a minimum. All right. Let's go ahead and solve for the vertex here. So we found the x value of our vertex is 3. So now we can plug that in, plug in 3, and solve for y. So we have y equals 3 squared. I'm going to use parentheses there. 3 squared minus 6 times 3 and minus 1. What we get is 9 minus 18 minus 1, which is equal to negative 10. Okay. Let's go ahead and start making a table of values just to organize some of our points. So x comma y. I'm going to put my vertex right in the middle because it's right in the middle of our graph. So 3, negative 10. We can go ahead and plot that point. Okay. Let's plot a few other points on either side of our vertex, which I'm circling right now. So we'll do the point maybe like 2. I also want my y-intercept, so maybe 0. And then let's do those other points of symmetry. So we'll do 4, and then let's also do 6. All right, so the y-intercept, if we plug in 0, vertex is 3, negative 10. If we plug in 0, we have 0 squared minus 6 times 0 minus 1, or just negative 1. So our y-intercept is 0, negative 1. Because we have symmetry over the axis of symmetry, I know that 0 is 3 away from 3. And I also know that 6 is 3 away from 3. Therefore, those y values must be the same. So that tells me we also have the point 6, negative 1. Okay, so you can go ahead and plot those points. It should look symmetrical. Let's also plug in 2. So we have y equals, I'm running out of space here, y equals 2 squared minus 6 times 2, and then minus 1. This is equal to 4 minus 12 minus 1, and that is equal to negative 9. And so again, because of that symmetry, we know that we have the point 2, negative 9, and 4, negative 9. Go ahead and sketch in that graph. Extend it all the way up, draw those arrowheads. This extends infinitely in the positive y direction. Okay. All right. Now let's graph 2x squared minus 4x. All right, so I noticed that this is in ax squared plus bx and then plus c. There is no plus c. There's no constant term being added. So we can use a placeholder 0 plus 0. All right, so that tells me a is 2, b is negative 4. So negative b over 2a is equal to negative 4 over 2 times 2. And we get 4 over 4, or 1. So the axis of symmetry is x equals 1. This has a positive leading coefficient, so that tells me that this opens up. A positive leading coefficient tells us that the vertex is a minimum. And now let's go ahead and solve for the vertex. Y equals 2 times 1 squared minus 4 times 1. We're plugging in this x value and solving for y. So what we get is y equals 2 times 1 minus 4, which is equal to negative 2. So our vertex is 1, negative 2. For the y-intercept, we have y equals 2 times 0 squared minus 4 times 0. We're plugging in 0 for x and solving for y. What we get is 0 minus 0, or 0. So the y-intercept is simply the origin. Let's go ahead and plot some of these points here. I notice that we've got our vertex of 1, negative 2. We've got our y-intercept of 0, 0. So then the next point, 2, must also be at 0 because of that symmetry. Okay, let's get one more point just for good measure. So let's do negative 1 and 3. I'm going to plug in 3 because I don't want to deal with those negatives. And I know that there's going to be symmetry over the axis of symmetry. So the y value that we get from x equals 3 is going to be the same for that of x equals negative 1. So y equals 2 times 3 squared minus 4 times 3. This is equal to 2 times 9, and then minus 12. So this is equal to 6. Okay? So we can go ahead and plot that as well. Negative 1, 6, and 3, 6. All right. Sketch your graph, nice and curved. Arrowheads going all the way up. There we go. Number 3, this parabola opens up because the leading coefficient is positive. Axis of symmetry, negative b over a over 2a. I know that a is 1, b is negative 2, so that tells me we have negative 2 over 2 times 1, which is equal to 2 over 2, or 1. Axis of symmetry is, again, going to be x equals 1. The vertex, if we plug in 1 here, we have y is equal to 1 squared minus 2 times 1 plus 1. 1 minus 2 plus 1 is equal to 0, so the vertex is 1, 0. This vertex is a minimum because this graph opens up. The y-intercept, if we plug in 0, so y equals 0 squared minus 2 times 0 plus 1, this is equal to 0 minus 0 plus 1, or just 1. Before we move on, I just want to point out some pattern that I'm noticing with the y-intercept that you may have noticed as well. I noticed that anytime we plug in 0 for x when a quadratic is in standard form, the y-intercept is just simply that constant term. So in number 3, here it's 1. Number 2, it was 0. Number 1, it was negative 1. And so we can see that in standard form quadratics, y-intercept is just that constant term. So we have 0, 1. If you recognize that pattern, that might save you some time. Otherwise, we know how to solve for it. Plug in x equals 0 and then solve for y. So a table of values, we have our vertex of 1, 0. We have our y-intercept of 0, 1. That tells us that we have the point 2, 1. And we'll plug in one more. We'll plug in 3. So y equals 3 squared minus 2 times 3, and then plus 1. This is equal to 9 minus 6 plus 1, or 4. So we have the point 3, 4, and negative 1, 4. Okay? So plotting these points, we'll start with our axis of symmetry, x equals 1, our vertex of 1, 0, and y-intercept of 0, 1. We have 2, 1, 3, 4, and negative 1, 4. Again, make sure that graph is nice and curved, draw those lines up, draw those arrowheads, extend it infinitely. All right, flip the page, we got a couple more for today. Y equals x squared minus 8x minus 3. First things first, this parabola opens upward because our leading coefficient is positive. Axis of symmetry, negative b over 2a. So we have negative 8 over 2 times 1. This is equal to 8 over 2, or 4. So the axis of symmetry is x equals 4. Because this opens up, our vertex is a minimum. And then our vertex, plugging in 4 for x, we can solve for y. Y equals 4 squared minus 8 times 4 minus 3. We get 16 minus 32 minus 3, which is equal to negative 19. So our vertex is 4, negative 19. Our y-intercept, if you've been noticing the pattern, it's just that constant term in standard form, so we have 0, negative 3. Let's go ahead and create a table of values. So our vertex, we'll put it right in the middle, 4, negative 19. Our y-intercept, 0, negative 3. By symmetry, that tells us that we have 8, negative 3. Let's choose one more point. I'm going to choose 3 and 5. So plugging in 3, we have y is equal to 3 squared minus 8 times 3 minus 3. That's equal to 9 minus 24 minus 3, which is equal to negative 18. So by symmetry, 5 evaluates to negative 18. Okay. So to graph this, we'll start with our axis of symmetry, x equals 4. And here's where we run into a problem. If we were to try to graph the vertex here, this would be off the grid. Because we have a 10 by 10 grid, we have to adjust our increments. All of these increments we're assuming are 1, but in order to include our vertex, let's go ahead and assume that they are 2. So I'm going to go ahead and mark that. That first increment is 2. That tells us that 5 down is now going to be negative 10, and 10 down is now going to be negative 20. This then extends our grid to be, instead of a 10 by 10 grid, a 20 by 10 grid. All right, so then our vertex is going to be at 4, negative 19. That's going to be halfway in between 18 and 20. Negative 18, negative 20. We have 0, negative 3, so that's going to be just underneath negative 2. And then we also have 8, negative 3. We've got 3, negative 18, so that would be right here, and 5, negative 18. Go ahead and sketch in that graph, nice and curved. Arrowheads pointing up. That nice U shape. All right. Let's try another. So number 5, this parabola has a negative leading coefficient, so that tells me that it's opening down. Axis of symmetry is negative 4 over 2 times negative 2, negative b over 2a. This is equal to negative 4 over negative 4, or 1. So axis of symmetry is x equals 1. Next up, our vertex. Because this is opening down, our vertex is a max. To find our vertex, we're going to plug in x equals 1 into our equation. So y equals negative 2 times 1 squared plus 4 times 1 plus 5. This is equal to negative 2 times 1, which is negative 2, plus 4 plus 5. This is equal to 7. So our vertex is 1, 7. Our y-intercept, again, is that constant term, 0, 5. Creating a table of values, x, y. Let's start with our vertex, 1, 7 in the middle. We'll do 0, 5. That tells us that we also have 2, 5. Let's do one more point, negative 1 and say 3. So evaluating for 3, y equals negative 2 times 3 squared plus 4 times 3, and then plus 5. This is equal to negative 2 times 9, that 3 squared, plus 4 times 3 is 12, plus 5. This is equal to negative 1. So we have the point negative 1, 1, and 3, negative 1. Let's go ahead and plot these points. Axis of symmetry, x equals 1. We've got a y-intercept of 5. We've got a vertex at 7, 1, 7. We've got 2, 5. And then we've also got negative 1, negative 1. We've got 3, negative 1. And so we can see that this is the parabola that opens down. So go ahead and extend those lines, draw those arrowheads, nice U shape. Okay. Last one for today, we have y equals x squared minus 1. So this parabola, the leading coefficient is 1. Notice that this could be rewritten as x squared plus 0x minus 1. That middle term here is 0. There's no linear term here. So we can say that coefficient is 0. The parabola is going to open up because our leading coefficient is 1. It's positive. Axis of symmetry, we have negative b over 2a, which is just 0. So axis of symmetry is the y-axis, x equals 0. Because this opens up, our vertex is a minimum. And then our vertex, if I were to plug in 0, y equals 0 squared minus 1. That's just equal to negative 1. So our vertex is 0, negative 1. And likewise, our y-intercept is also 0, negative 1. So let's go ahead and plot some points. So we have 0, negative 1. We got to get a few more, so I'm going to choose 1 and 2. If I plug in 1, we get y equals 1 squared minus 1, or 0. So that tells me that we have the point 1, 0 and negative 1, 0. If I plug in 2, we get y equals 2 squared minus 1, or 4 minus 1, or 3. So then we have 2, 3 and negative 2, 3. So we'll start with our axis of symmetry. We have 0, negative 1. We have 1, 0, negative 1, 0. And we have 2, 3 and negative 2, 3. We'll sketch that graph. There we go. All right. So these have been our notes on quadratic functions in standard form. We're going to get a lot of practice, so we'll see you tomorrow. Have a great day, everybody. Goodbye.